15 strange galaxies challenge our science. How can it be that they existed before the Big Bang? Scientists are desperately seeking explanations for observations that show that our old cosmology cannot be right. If we apply old standards, the galaxies observed by the James Webb Telescope should never have existed. But they are real. They are genuine. And we are witnessing a cosmic revelation that calls into question everything we previously thought we knew about the origin and development of the universe. A quote from John Mather: "If galaxies in the universe were so large and developed so early on, then perhaps we need to rethink how quickly matter was able to form, and whether we have understood the beginning of the universe correctly at all." The 15 galaxies that the James Webb Space Telescope has discovered in the depths of space show structures that are far too old, too large, and too developed to fit into the old model of slow cosmic evolution. Some of these galaxies contain billions of stars, are compact in structure, and even show signs of black holes. All of this should not be the case a few 100 million years after the Big Bang. So the big question is, how could these galaxies form so early? According to the standard model of cosmology, gas clouds would not have been allowed to condense so much until much later, so that stars and galaxies could form in mass. But the reality in space does not seem to conform to the formulas of our science. Some researchers speak of a major cosmological rethink. Others suspect previously unknown physical processes that can provide answers to far more than just the existence of 15 impossible galaxies. Still, others see evidence of traces of an earlier universe. Could it be that the universe renews itself in cycles? Or that the early days of the cosmos were actually quite different from what we previously thought? Perhaps the James Webb Telescope has not only discovered new galaxies, but has opened a window to a new reality. We could reach new dimensions through new insights, where time, space, and origin no longer play a role. These 15 unexplainable galaxies could point us in a direction we hadn't previously considered. Our universe could be much deeper, more mysterious, and more wondrous than we ever imagined. And we are just at the beginning of this discovery. What do we really know? It may sound paradoxical, but the more we find out about the universe, the more it seems that our knowledge is just a small drop of light in an ocean of darkness or ignorance. Modern science has made enormous progress in recent centuries. We can accelerate particles, observe distant galaxies, decode DNA, and program artificial intelligence. Our formulas somehow work, but they do not deliver the truth. Our technology works, but it does not lead us to a goal, but to even more questions and challenges. Much of our knowledge is based on models that are supposed to represent reality. But these models are not necessarily the truth. It's likely that our science is only scratching the surface of the truth of our world. Gravity is actually considered to be a well-described force, but we still don't know exactly what it is. And there are concepts that suggest that gravity may not even exist. These alternative concepts may even provide evidence that is at least as good as those that claim gravity is a mathematical or physical incontrovertible reality. Dark matter and dark energy together make up about 95% of the universe, and we have never seen either of them directly or scientifically proven them. Our standard models of cosmology and particle physics have been extremely successful, but they always fail when it comes to the margins. They cannot fully explain the Big Bang in all its dimensions, nor singularities, the interior of black holes, or consciousness. We have to be realistic. Science is still a rather uncertain method of gaining knowledge, and it's certainly not a collection of irrefutable truths. In a way, science is always synonymous with not knowing, but wanting to know, especially when it comes to the universe, which we can only observe from afar and at a distance, but cannot travel and measure ourselves. We have very limited means at our disposal. The James Webb Space Telescope is certainly one of the best instruments ever created by humans. But even the best technology has its limits. Webb can observe and analyze, but it cannot provide explanations or establish the urgently needed connections. Even in our age of constant technological progress, doubt, questioning, and the need for constant self-correction remain. So when the James Webb Telescope discovers galaxies that shouldn't really exist, science must not see it as a failure, but as progress. Once again, science must question itself, and that can only mean progress. Webb's mission to the edge of the universe. The JWST was developed to answer some of the biggest questions in astronomy. How did the first stars and galaxies form? Are there habitable exoplanets? How did planetary systems develop? With its 6.5-meter primary mirror and highly sensitive instruments, the new super telescope can capture light that has traveled more than 13.5 billion light-years. In addition to its huge primary mirror, the telescope has an arsenal of innovative instruments that will enable it to study the oldest and most distant objects in the universe in unprecedented detail. With a near-infrared camera, the telescope captures infrared light from distant galaxies, stars, and exoplanets. NIRCam can also detect faint objects that are invisible to other telescopes. The near-infrared spectrograph analyzes the chemical composition and temperature of celestial bodies based on light patterns. It can examine up to 100 objects simultaneously, which is unique so far. MIRI is already a superstar in its own right. Every fan of the telescope and every amateur astronomer knows the nickname of the mid-infrared instrument. MIRI detects light in the mid-infrared range and can capture particularly cold objects, such as dust clouds or exoplanets with low temperatures. MIRI thus makes it possible for the first time to analyze structures that have so far remained hidden from the human eye. At a distance of about 1.5 million kilometers from Earth at Lagrange Point 2, the telescope is so secure and undisturbed in space that it provides images of unique sharpness and depth. With its unparalleled sensitivity and advanced instruments, the JWST can identify the first galaxies, check exoplanets for signs of life, and unlock the secrets of the epoch immediately following the Dark Ages. The main objectives of the Webb mission are to study the first galaxies and stars after the Big Bang, explore the structure and evolution of galaxies, and study star formation processes and planetary systems. The JWST was designed to give us a view of the edge of the universe. Thanks to its range of more than 13.5 billion light-years, we are looking directly at the boundaries of the temporal universe. The telescope has already discovered some of the oldest known galaxies, which were formed only a few 100 million years after the Big Bang. These observations shock science, but they also help us to better understand the history of the universe and to develop new physical theories. The JWST is definitely a milestone in the exploration of the cosmos and will surely deliver more groundbreaking discoveries in the years to come. The Dark Ages are a problem. In ancient cosmology, the Dark Ages of the universe were considered one of the most fascinating and enigmatic epochs of cosmic history. The epoch directly after the Big Bang was still completely dark. That was long before the first stars lit up the universe and galaxies were formed. During this age, the universe was filled with neutral hydrogen, which did not emit any light. At least, that's how researchers saw it until now. This darkness poses a problem, because it's a key to cosmology and extremely difficult to research. But why is that? It's actually quite simple. Since no light sources existed during the Dark Age, there are hardly any direct ways to observe this epoch. Astronomers have to resort to indirect methods, such as analyzing the cosmic microwave background or using theoretical models. The Dark Age supposedly ended with reionization, a phase in which the first stars ionized the interstellar gas and the universe became visible for the first time. James Webb should actually show us the phase in which the first stars were formed. But we don't see any young galaxies or stellar nurseries in any of the images. We see galaxies that are fully formed and highly developed, and in droves. How exactly the first stars and galaxies were formed remains an unsolved mystery. Even highly developed telescopes like James Webb reach their limits when it comes to their images not showing what scientists have predicted. The research now requires new technologies to be able to look back even further. If we want to know whether there was a dark age at all, we have to capture the light of even older stars and galaxies, until we are really sure that we have arrived at the first stars. Then we might be able to see if it was really dark before these first stars. However, we can only say for sure if there is no light behind the first stars. There would have to be complete darkness. But what if this darkness does not show up? Then our old cosmology is truly at an end. Scientists are currently working on radio telescopes that could detect neutral hydrogen signals from this epoch. Projects like the Square Kilometer Array should provide insights into the dark age in the future. Research into this era could not only help us to understand the true development of the first structures, but also provide answers to fundamental questions about the evolution and origin of the universe. What does Jade's GS Z14-0 really reveal? Jade's GS Z14-0 is one of the galaxies that shouldn't actually exist. It was discovered in May 2024 by the James Webb Space Telescope. The JWST Advanced Deep Extragalactic Survey, or JADES for short, is one of the most successful projects for identifying the oldest galaxies in the universe. This galaxy emitted its light 13.5 billion years ago to reach Earth. Its light traveled an incredibly long time through space and time. Today, the light shows us a piece of the past. This means that we see the galaxy in a state that existed only 290 million years after the Big Bang, as determined by the travel time of the light. The galaxy has a diameter of about 1,600 light-years. This is small compared to our Milky Way, which has a diameter of 100,000 light-years. Although the galaxy is small and could therefore be young, it's significantly brighter and more massive than was expected for galaxies at that early epoch. This suggests that stars and galaxies may have formed faster and in a completely different way than previously thought. Surprisingly, oxygen was detected in Jade's GS Z14-0. This fact argues against a young galaxy, since heavy elements like oxygen are only produced by several generations of massive stars. The existence of oxygen indicates that the galaxy was already in an advanced cycle of intense star formation. These findings challenge the standard model of cosmology. Not only is the old picture of galaxy formation being questioned, but the theories of the Big Bang and the development of the universe itself have been shaken to the core by the discovery of galaxies like this one. Click subscribe now. There are many more exciting videos to come.